Hey there, I'm Stefan Papadakis. We're here live at the 2019 Sema show, and we're continuing the build of our 2020 Supra B58 engine. The first day we put the crank rods and pistons in. Yesterday we did the cylinder head and part of the valve train. Today we're going to finish the valve train, the intake manifold, turbo, and wrap it all up. So join along. Right before we get started, I want to thank a couple of guys, Matt Orwig and We're a Cheeto. Thanks, guys. And let's get started. Yesterday we left off, we had the intake cam installed and all of the double rocker arm set up. Next, we're going to put in the valve springs that hold the intermediate rocker arm in place. So I'm going to put some gloves on and then we'll get started. This has been pretty fun the last couple days, having the ability to kind of share the whole project. It's a little stressful, you know, kind of doing it live, but I don't know, like it's that unique experience that you really don't get to do. It's like you're sharing something that you really enjoy with a lot of other people here at the show and then also online, so thanks for watching. All right, so we're gonna install these springs, and what they do is they hold the intermediate rocker in place. So if you can come around, so the way the system works is the intake cam lobe pushes down on this intermediate rocker. The intermediate rocker then pushes down on this lower rocker and then activates the intake valve. So these are not just floating in space. This spring will hold them in their proper location. They take a special tool, SST or special service tool, and I have one in my drawer, which is this right here. And I'll show you how this works. You have to gotta load up the spring. You got that?
Got it.
Yeah, cool. So, gotta open this up a bunch. That gets loaded up there. Then these little grooves push on the spring. It compresses it. There's a little lock. And then we slide it underneath the intermediate rockers, and then I let the tension go, remove the tool, and then it's in. And it's possible to install these where the part of the spring's not totally engaged. So I'm actually gonna get my flashlight and confirm that it's in there properly on each one of them. And I've done this a few times now, so I have a good feel for it. So we'll install the other 5 and then keep moving on the next part. This is one of those things that, you know, you kind of, there's a new engine and they have newer technology, and at first you kind of don't always like, but I think with the right tools and the right techniques, it's not so bad, especially if it helps performance. And so like one of these sides, I didn't get the spring properly in. So that one's in. Gotta make sure that the cam lobe is on the back side of the cam lobe, so it's not trying to depress the rocker arm. They actually make another part for this special service tool where you hold the special service tool and load up the springs, but I found it to just work just fine and a little quicker if I don't use the secondary attachment. Oh, no, missed it. Yeah, if you guys see a spring fly across, keep an eye on it because I'll need it. All right, so that one's in. And again, I'll turn the cam so it's on the back side of the lobe, so it's not trying to open the valve. And this one, this piece on the camshaft is the cam crank pickup. So you just have to rotate that so the tool doesn't hit it. It's good. 2 more. It's actually kind of fun using this tool because it works so well. One more. So these are one of those areas that when we're developing an engine, we don't really know what we'll get away with. So the factory red lines on the engines, I think a little bit under 7,000, but eventually we'd love to try to get over 8,000 or even 9 in RPM. So in the future, we'll be working on trying to figure out, how to make the Valvetrain and high RPMs. So that's why development is kind of always ongoing. In the past, what we've done is we try to make the power that we want to make, like on our old 4-cylinder engine. And then once we got to the power we wanted to make, which was about 1,000, then we tried to make another, to get it to run out another 1,000 RPM. So we were up to 8,000 originally, and then now we're running those engines up to 9,000 RPM. Okay, so all the springs are in. I'm gonna double check with the flashlight and make sure they're all in the proper groove. And they all look good. And then they all look seated down, so those, done. That's how you install it. And then we're done with the tool. The next would be, we're gonna put the exhaust cam in, but before we do that, I don't know if you built some like inline 4s and especially the inline 6s. When you install the exhaust cam, one of the lobes is pushing down, is trying to open up the valve. And so when you go to install the cam, it doesn't want to sit in the hole in all of the crank journals. And there's actually another special service tool, SST, that pushes down on those 2 rockers and opens up the valve, gets the rocker out of the way so the cam can sit flat. So when you tighten it, you don't have to worry about breaking the cam or anything. So that tool is this one. So it actually bolts to the cylinder head, and it has these little teeth. If you come around here, you can see how it works. So if you watch the cam, it's not sitting in the crank journals yet because the lobes are pointed down and the rocker arm is not, you'd have to bolt the cam down and push the rocker arm down to open the valve. So you have all that spring pressure resisting you. What we're gonna do is take that tool, bolt it in. Once I get the 10mm socket. It's always the 10mm you gotta find, right? It's missing. So no problem, I got 10mm. Tighten these down. Just snug. And then grab another ratchet, which I believe it's a 17. Okay, and then watch this. So as you start tightening down it starts pushing down the rocker arm and opening up the valve, and then it allows the cam to sit into the groove there, just like that. But first we got to put the chain on, and in order to get the chain on, so the crankshaft is locked into top dead center. We need a way of locking the camshafts to top dead center, and there's another special tool for that. But first we want to get the chain. So some of the people watching yesterday, like, the chain fell down into the timing cover. There's actually like a little pin that stops the chain from falling all the way in. And you just need some needle nose pliers, and I can grab the chain. And bring it back up. And there's a couple of ways of installing this. One is to take the cam gears off, but I found actually having the cam out and then putting the chain on and then putting that in was the best. So the service tool that we need, let me see here. I'm gonna get a towel real quick to wipe the oil off my hands. Okay. So I actually, before I pulled apart the engine, I'm gonna squeeze around you here. I've actually marked, I put little scribe marks. So I've got a little cheater mark on the alignment of the cam. And a small little, which I'm gonna lift this up. So I can get it mostly lined up with my scribe marks on the cam. I scribed the top of the cam and then a matching mark on the cam cap. So that should be lined up. But to confirm it, you put on the other special tool, which is this one. So this big bridge here bolts to the head, which we'll bolt on in a minute. And then these teeth grab onto flats on the camshaft, and they lock it in the top dead center. And it's a little bit cumbersome, but it's like super positive. Like old engines I worked on with timing belts, you kind of line up these like kind of vague marks, and then you line up the cam gears on like the plastic cover, and usually works pretty well. But it is a little, it's not always super positive. This one we put on the bridge, and I'll bolt that on with a couple of 10 mil. Done. And then, so we've got the intake cam, so it fits on that flat, and it should fit on and then sit flat. And see how it's not? That means I've got it off a tooth. So we are going to take the exhaust cam out. We need to go this way. I need to get a wrench to move the cam. So I've only really done this 2 other times. As you do it more, you know, I'm sure there's some mechanics that have worked on this a bit that are like, oh, I could do that in a couple minutes, probably. So I've moved it a tooth, I think. Need to go more. Just like that. So now that we've got that lined up, I can put the 2 bolts in it, and then it locks the intake cam in position. And then we can work on the exhaust cam. See how it's off a little bit? So we need to lift this up. We'll move 1 tooth. And then now everything's locked into 0. I'll put the other 2 bolts in. Sometimes this feels like it's taking a while because it's just live and it's a little tedious, but whatever, it takes 10 minutes to align the camshaft. That's just what it is. So then, once these are all snugged up, we're confident the cam is all installed and aligned. So the crank is locked in down here in top dead center. The intake cam is locked in with these teeth, and then the exhaust cam is locked in here. And the chain is a little bit loose because we don't have our tensioner in there yet, which goes in here and pushes on the chain. But we don't need that yet. But now that we got everything lined up, we can go put the exhaust cam caps on. And they're all numbered from front of the engine to the rear of the engine. The front of the engine is always where the crank pulley is, regardless of where the timing chain is. So where the timing chain is doesn't change the front of the engine. So this is number 1 to 6. And it's always the front of the engine, not the front of the car. So like in a Porsche or something where the engine's kind of backwards and the pulley's in the back of the car, the front of the engine is actually the back of the car, which would be the cylinder number 1, is the front of the engine. So all the cam caps, one of them is this, which is the mechanical fuel pump stand. And that's what this lobe here with the 3 lobes is actually the lobe that pushes and pumps the mechanical fuel pump for the direct injection. So those are all Torx bit. So I like to get them started so you don't cross thread them, and then I'll get my impact gun and just zip them in. And then I'll come back and torque them all. And then once I get past this point where the cams are all torqued in, I'll take some questions. So if you want on the chat, put any questions you have. And then Jen back here, that's on the production side, she's gonna look through them and then pick a few, and then I'll answer them on the feed in a few minutes. So if you're just joining us, we're here at the 2019 Sema show, and we're building a 2020 Supra engine, the B58, live here at the show. And the plan is to try to make 1,000 horsepower with this engine. We've modified it a bit with different crank rods and pistons. You can go to other videos that we've posted on the Papadakis Racing YouTube channel, and you can see the full teardown in the engine, and we did a whole profile of all the parts we're changing on it. So those are all videos that are on the Papadakis Racing YouTube channel. And we're, here live at the show with actually an audience. Okay, so those are all snugged. So now I'm going to torque them down to their spec, which is 7 foot-pounds. And I appreciate, it's like people on the stream have been watching, making sure I torque everything, or maybe waiting for me to miss something. So I guess if you do see something, let me know.
What's your opinion on the digital torque wrenches for engine building?
So I'm cool with the digital torque wrenches. The reason I like the dial one that I'm using right now is for when I go from like different bolt to different bolt, I might have a different torque. I don't have to keep setting it to that new setting. It's 0 to whatever. So for this one, it's 7, and I can go over to something that's 15. I can just change the socket, boom, 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 and I feel it's a bit quicker. Yep. But sometimes you can't always see it, and then I like the clicking type torque wrenches. So you can be torquing it, and it's just like you get that positive feel. The digital ones, I don't know. I like the positive click sometimes. So the digital ones are cool. The reason I got the digital one for this engine is because it'll do angle torque. And that's, I mean, now I have thousands of dollars of torque wrenches, but you know, if you do it for a living, then I think it's totally money well spent. If you're just doing it for a hobby, then you kind of just do what you can get away with. Okay, so now that the exhaust cam is all bolted in, except for the one main cap that I can't get to here, I'm gonna release the tension on these exhaust valves with the 19, or the 17, which I did not put back, which should be right there. So now we'll take the special service tool off of the exhaust cam lobes there, and then unbolt it. So we're kind of also hoping with the video is, you know, it's fun to kind of watch the inside of one of these engines go together, but it's also so new, and a lot of people want to modify them, that you kind of, once you see somebody do it once, you're like, oh, I could do that. So I'm hoping to get it, in depth enough here with these videos. So if you're a mechanic and want to start messing with your 2020 Supra, you can feel pretty comfortable after watching this stuff. Okay, so the next is we're going to pull this tool off. The alignment for the cam crank. And then we will put the last cam cap on, which is right here, number 7. And I showed this ratchet off yesterday, but I really like this one. It's a 1/4 inch drive ratchet, but with a 3/8 head on it. So I can use all the 3/8 tools with a 1/4 inch ratchet. Torque them both down to 7. Okay, and then I'm going to look and remember, I remember torquing all of these, so I'm confident with all that. This is part of the timing chain guide setup for the top here. So we'll get that on. Which I think is that size, yeah. Those get torqued on. Okay, so now all the timing guides are on, everything's aligned, and then we can put the timing chain tensioner on, hydraulic tensioner, which is this piece. And this is hydraulic tensioner, so it uses oil pressure and it pushes on this piston and it keeps the right amount of tension always on the chain, and then it never needs to be adjusted. So that's why nowadays, you know, you don't have engines that need adjustments for the timing belts or Valvetrain, because it's hydraulic. It's hydraulically adjusted throughout the life. Jen, are you getting some questions going? Okay, I'm almost done here. Done. And then we can pull the crank alignment tool out. I'll get the special tool to turn the engine, and use this. And we can turn the engine finally. And it feels good. Cool. So the Valvetrain's done, and then next we'll work on the variable valve lift setup. But first, let's take a couple of questions.
So Scotty 305 wants to know, does this engine have an electric oil pump control in its stock form? And if so, did you keep it?
Yep. Scotty
305.
305. Thanks, Scotty 305. The question is, does the oil pump have a electric control? So the answer is yes, and what that means is that the oil pump uses an additional solenoid that it adjusts the oil pressure. So the ECU can control the oil pressure on demand. We are still using that, because if you don't control the oil pressure with that solenoid, you have like 150 psi of oil pressure, which is really high. So what you do is you duty cycle that solenoid and you can lower the oil pressure. Essentially, you can program in the oil pressure that you want. So we programmed in about 50 psi at idle, and then by 3,000 RPM, we ramp it up to about 80 psi and hold it there throughout the whole RPM range. That's a bit conservative. That's quite a bit of oil pressure. But as we ran it a couple days on the dyno last week and we pulled it apart, all the bearings look perfect, like brand new still. So we're gonna stick with that for a little while. And that's one of those things, like the newer technology, at first you're like, oh man, what are they doing? This is so complicated. But then once you learn to control it, you can appreciate it, because now we can get whatever oil pressure we want. And the oil pump is actually larger than it needs to be. So if you decide to change some of the oil clearances or whatever, or the engine oil gets really hot and gets thin, then you can demand more of the oil pump and still have the oil pressure that you would like.
Vesa Urorinen says, are you using the OEM timing chain, and do you think it's okay, or will it be a limitation?
Vesa, so the question is, Are we using the OEM timing chain, and do we think it's going to be sufficient? So we are using the stock timing chain, tensioner, the whole drive system for the timing. It looks fine. On our 4-cylinder engines, we've used the factory stuff with really great success. The timing chain on the back of the engine theoretically is actually more reliable, should be more reliable than on the front, because there's less harmonics on the back of the engine than when you're driving off the front of the crankshaft. So we're pretty optimistic that the stock timing chain should deal with whatever we're asking of it.
Ray Brewer wants to know, was this head ported at any time after disassembling it?
Yep, so Rev Brewer?
Ray Brewer.
Ray Brewer, oh, Ray Brewer. Thanks for the question. The question is, was the head ported? The answer is yes. We did a bowl port behind all of the valves, and we opened up the exhaust ports a little bit as well. We need to be a little conservative because we don't know where the water ports are, and if you just keep making the holes bigger, you can actually grind into like the water system in the cylinder head, so we've got to be a little bit conservative at first. We actually profiled a bunch of that in the second video of parts that we did on the engine, so if you're interested in that, check out some of the other videos we did on the YouTube channel, and then we show how we decided how much to port by putting the cylinder head on the flow bench and flowing it and everything. So yeah, thanks for the questions.
A couple questions you didn't get to yesterday.
And there's a couple questions we didn't get to yesterday. One is the dual exhaust limiter or the integrated exhaust manifold, and at lower horsepower ranges, 700-800, I don't think so, especially at lower RPMs if you're trying to stay below 7,000. If you're trying to make power at 8 or 9,000 and make 8 or 9,000 RPM and trying to make 1,000 horsepower, it could potentially become a bit of a limiter. We're not there yet. We're going to see what we can get out of the 2-port exhaust head and then go from there. The other question was from DJ Wraith, was the cam duration lobe. I don't know what you meant, so if you could re-ask the question again on the chat and be more specific, we'll try to answer that one. And Elrod Jenkins, details on the turbocharger. We're using a BorgWarner EFR 9280, which is sitting here on the table, and we'll be installing that here in probably like an hour. Any questions from anybody here? Yeah.
As a longtime engine builder.
Do you mind?
Yeah, sure.
Yeah, okay.
As a longtime engine builder and a very good engine builder, what do you see in any kind of built engine where, oh, I see that, is this engine going to blow up? Not like when it will blow up, or sorry, if it will blow up, but when it will blow up. You see that one little thing, you think, oh, they probably did that for all of inside. This thing's going to go anytime soon. Because I'm sure you've seen it happen tons and tons of times. You're like, guys, that right there is a problem. You've totally missed it.
So the question, yeah, do we see anything that like stands out as like, oh, that might be a big problem with the engine? Not really. The one scary thing is the intake rocker arm setup. If we're trying to go to 8 or 9,000 RPM and having these two rockers, we don't know. So that's one of the really big questions, is how much RPM can we get out of this valve train? And then if we reach a limiter of maybe we need more spring pressure, like how much work do we have to do to make a custom spring with maybe more tension that could keep it all together? Yeah. So that's the one thing that's a really an unknown and something that we'll find out. Yeah, yeah, thanks. Any other questions? Okay, we'll keep going. So the next thing I'm going to do is put the last intake cam cap on. And what that one does is it is the stop for the variable cam lift, the variable valve lift. So this is the motor that controls the variable valve lift. And we are going to still install it, but we're going to set the variable cam lift to maximum. And then we made a little lockout. You drop the tools, but don't drop the parts. And you can manually adjust it. So let me bolt this thing in. So the way this setup works is this little motor adjusts this eccentric cam, and then it adjusts the rocker ratio of the intermediate cam, and it can change the ratio from very little lift to, its maximum lift. We just want maximum lift for our setup. So after installing the little motor, I can adjust it with the screw on the back. If you come around, I'll show you. So see, when I turn this, it's turning this gear and it's changing the lift of the intake camshaft. Yep. Oh. So this is the last cap. And if you see this little bracket, this is a piece that we made. So once we get it to maximum, we can mechanically lock it to stay there. And then we actually don't hook up any electronics to the system. Actually, I need to. There's a little trick to getting this whole thing together. Is I need to lift this up, go to maximum lift. This is not an OE part, so this is something that we made. So we go to maximum lift. Yeah, if you can get the camera in here, you can see this little stopper bolt. This was a cool part, but kind of need to have this idea of how you want to make it. So I sketched it out on paper and then built it in CAD and then actually made it out of 3D print, out of plastic, and then bolted on, make sure everything was perfect, and then we made it out of steel. So the way this works is this pin goes all the way to maximum, and this bolt comes in and it keeps it mechanically held at maximum. And I've drilled both of the bolts. And I'm gonna put safety wire in a way that it stays tight. So can you see the details there?
Yeah.
Cool. So eventually it's gonna come around like that. So I'm gonna hold it at the length that I want the twist to go. Come back over here, twist it. And so see how it's pulling it around, it's trying to tighten it. And there's another hole drilled here in this other bolt. And I've installed the safety wire in a way that it will try to keep it tight. Done. And then I'll cut it. Fold it over. So there, it's all safety wired. Won't come out. I'll double check that I put everything on. Look at my table. And I'll put the valve cover on. And another neat thing is, so this is a variable cam. Timing, so these are the variable cam gears. And the solenoid that controls them is actually on the valve cover, these small little plastic solenoids. So the ECU connects to here, and it can duty cycle those cam gears. And with oil pressure, it changes its timing relative to the crank. And it's usually a huge increase in low-end torque by advancing the intake cam, and then you can get some more high-end RPM power by retarding the exhaust. There we go. And this is a plastic valve cover or a composite something valve cover. So it's pretty lightweight, but you got to be careful tightening it. You want to do it in sequence so you don't crack it. So I'm just going to tighten everything until it sort of touches. And then I'm going to hand tighten it after that all the way down. And this one's been Cera coated red. And if you look here, you can see where some of the red is sort of burnt off. On the dyno last week, we had some issues, which when we come out with the video, I'll show you guys what happened. It's kind of exciting, but we worked through them.
How much RPM you had on the dyno?
We've been around 7,000 or so far, and it seemed pretty easy. What'll happen with we're still running the stock camshafts, so that can be a limiter with how much power you can make at higher RPM. But we're also working on some larger camshaft options for us as well with this. But that's the fun part, right? Is kind of have that goal of what you want to make for power and RPM, and then just start working towards it. Figure out what the next limiter is, modify that, or get a new one built, and then keep going.
Are you working the cam loads or a complete like a new camshaft?
For right now, we're working on a regrind cam, but in the future, possibly full billet stuff. But those sort of things take months to have designed and built and R&D'd and stuff. So we're kind of at the limit of what we can do within weeks instead of months. Okay, valve cover is all installed, and we're not using the direct injection. So the mechanical direct injection pump actually goes here. We made a little billet Papadakis Racing logo block off plate. That's installed. We're all good there. And then we can move on to the spark plugs. And I always like to number all of the spark plugs. So they're all numbered 1 through 6. And we're actually using the factory plugs right now. It's a really unique looking plug. And we're still searching for a little bit of a colder heat range for them. So that's something we're working on. I'm in the wrong hole. Because there's two holes. There's one for the direct injection and there's one for the spark plug. And the direct injectors we're not putting in this. We've actually plugged all of the holes. And I like to torque all of the spark plugs because the spark plugs do transfer heat in between themselves and the head. And if you have a consistent torque, I just believe that you have a consistent transfer of heat and you know it's tight and nothing should come loose. So I get a lot of questions about how I got started in, kind of doing this kind of stuff. And did I go to any schools? And I didn't. I just graduated high school, and right after I knew I wanted to work on race cars. And I had my own car that I started working on its engine, just basic stuff like the exhaust and air intake and spark plugs and stuff like that when I was like 16. And I had some buddies that taught me how to, like when we lowered the car, we didn't have a bunch of money for like all the suspension and everything. So we'd pull the suspension off and we cut the springs to make it lower. You kind of, out of that necessity of not having a bunch of money to be able to drop it off at a shop, you kind of learn how to do stuff more yourself. And then after high school, I worked for this place called JG Engine Dynamics, and they built some racing engines or, road racing engines and stuff like that. And I wanted to work there because I wanted to see, how much I could learn from them. So I started off just sweeping the floor and then answering the phone, and eventually I got enough trust for them to start, working on some of the customer cars and just got a lot of experience, not only from the working at that shop, but also working on my own car. And I was always racing in parallel, the front wheel drive drag racing. And when you're doing the drag racing, typically you're braking and blowing stuff up. So as I, break the transmission or axles or break the motor, work on it myself or with my friends, and then just kept having experience that way. And that was in the mid 90s, late 90s. And at the same time, the import scene, sport compact drag racing scene was really starting to rise, and kind of grew with it. My race car for the street turned into a full-on race car for the track, and started going to all the Bally imports and all the other drag races, and just kind of grew with it and evolved with the whole series and the whole industry. And the Fast and Furious movie, when it came out, blew up the whole industry even bigger, and was kind of right place at the right time, and sort of made the best of it, and evolved into where we are today. So if you're into any of this stuff, just get a project car, and not an expensive one, but something easygoing, and just start wrenching on it. And you're going to learn so much, especially nowadays because of YouTube and forums and all that stuff. There's so much information out there on how to work on everything. Next, we'll put the coils in. So these are coils, the direct on spark plug coils, coil on plug. So there's a little spring in here that touches the top of the spark plug, and these just bolt right on to the valve cover right there. So one, these are numbered 2, 2, 3, 4. So we're getting there. We'll get to some of the real fun stuff soon, which is the turbocharger and the intake. So if you're in the chat and you're online, intake, turbocharger or intake manifold first? Jen will look and watch the feed, and we'll see what gets the vote, and we'll start with that one first. Should we go to anything else, Jen, while we're...
I can't watch and ask questions.
Okay. I'm overloading her back there.
We can't put it up on the
Simon Trent 8000? Is the direct injection used to increase spool up? That's a good question. I have limited experience with the direct injection. Typically what I've seen is it has a little bit better knock resistance, so you can run a bit higher compression with a little bit lower knock fuel, and it can be more efficient as well, so you can make the same power with a little bit less fuel. But I'm not sure about the spool up. It's a good question. I wouldn't think so, because I don't think the direct injection helps with exhaust energy so much. And the spool up is mostly relying on exhaust energy to get that turbine wheel spinning, to get the whole turbocharger spinning, to get the boost up quicker. All right, so turbo. All right, so we're going turbo first, and it's on the front here. You'll notice there's 2 exhaust ports. We've got a special turbo manifold from Full Race with those matching 2 exhaust ports, and the turbocharger and everything is already bolted on. These are our little gaskets, which I don't think I just put on correctly. There you go. So we've got gaskets. Can somebody help me? Can you help me out? Grab that bolt. And then so I'm gonna hold the whole, yeah, one's fine for now. I just need to, once I get one on there, or once I get the manifold on there, just to make sure it doesn't fall off. This assembly is like 30 pounds and it's like awkward, so give me a minute to, all right.
Make sure you tighten the muffle bearing.
Right? Cool. Awesome, thank you. So now I can let it sit and put the rest of the bolts on, or the nuts on. Like if you ever work on headers or exhaust manifolds, these are always typically kind of a pain in the butt because it's hard to get to the nuts on it, or the bolts or whatever it is. We're fortunate that it's out of the car, but yeah, if you ever put headers on, it's usually not that easy. And then, let's see, I've got wrenches here somewhere, ratchet wrenches. All right, hold on, one more try. So I know they're not on the top. No, did I not bring them? Oh, maybe I didn't bring the 10 ratchet wrench. That's fine. We'll use a 1/4 inch with a shorty.
How does the engine mount and the downpipe work out on this engine?
It goes right above it. The mount's relatively low. Yeah, yeah.
How much boost?
We don't know that. Whatever we need to do to get to 1,000. So it could be in the 40s for all we know.
What's the spring pressure on the gates?
So we start at 10 psi, and you can usually get about 30 out of it before you have to go to a lot higher spring rate. So there's springs in here that give you the minimum boost pressure, and yeah, we start at 10 psi, just basic, and then we'll kind of go up from there. And the boost control is adjusted by the solenoid down here. So I actually do need a ratchet wrench to finish this, but because I didn't bring it, we're gonna finish that back at the shop and we're gonna move on. So I don't spend a bunch of time with the normal wrench and just tighten it. So we'll finish the turbo. Don't let me forget. These are vacuum lines that go to the intake manifold. This is the turbo speed sensor plug. We can actually monitor the speed of the sensor. And then the oil plumbing, oil in and out of the turbocharger. So those are down here. Got a bunch of bags of a bunch of stuff. So first, we're going to find the oil pressure feed to the oil, or to the turbocharger. So this is a factory. This one is the crank pressure. We actually monitor the crankcase pressure, and the hole in the block actually goes into the crankcase, and we can put a sensor, a line to this to a sensor, and see what the pressure is in the crankcase. And then you can measure, get an idea of if there's much blow by from the rings or whatever. So that's that. But we're not hooking that up till we get on the dyno. So we'll actually leave a little cap on it. And then the turbocharger oiling comes from this flange. And we have another fitting that screws right into the block. Oh, that one is, bear with me. What did we, oh, this is oil pressure. Sorry, oil pressure for the other side. The oil, this one is the oil line. So this is oil for the oil pressure. Just got a little O-ring seal on it. So that slides into the block here. And stock, it has these hard lines that transfer oil to the turbocharger. Because we're using a different turbocharger, we're running a little bit different oiling system on it. We've modified it for the larger turbo, and that's one of the pieces. That'll be a 9/16 wrench, which I've got here. So whenever there's an AN fitting, I like to put a cap on it. That way, if it gets bumped into, you don't mess up the flange. And then you can see we've got a plug on this side. So pull the plug out and just install it. So this line delivers fresh oil from the engine to lubricate the turbocharger. And then after this, we will install the drain, which is always bigger. So this is high pressure oil in. And then on the bottom, what's cool about this stand is we will actually, I'll bring this up so you can see the bottom a little bit. And this is the drain, so the oil comes in, it lubricates the turbocharger, and then it comes out this line, and then it goes back into the crankcase here. And we've got another custom fitting. Which bolts in to the block and then is held in with this Torx screw. which I think is this size. Yeah. So that's tight. And then I've got this trick AN wrench. It's like an adjustable wrench, but it's aluminum, so it doesn't scratch the aluminum AN parts. Just large enough to do the dash 8. As I say that, I go grab another wrench that's metal. So I think oil might come out of this. So I'm gonna put this rag below it, so it does leak out. Oh, no leak. And that goes in here, and that will finish the turbocharger installation. And if you look, this is like a heat-resistant wrap on it, on the oil line, because it is pretty close to the turbine housing, which gets really hot. So it's usually a good job to have some sort of some like heat shield on it, so you don't overheat the line and then it, cracks and leaks or whatever. Done. Okay. So turbocharger installed. I got tools out everywhere.
The drainage by having it not roll at 190 degrees flow. Good.
Yeah, we haven't had any problem with any kind of oil drain issues. We found if it's just somewhat downhill, it's usually good enough, and if it's large enough, then it needs to be entering the pan above the oil level. But different engines, different turbochargers can have different varying degrees of the needed feed versus drain. All right, next, let me clean up a little bit. So guys, how are we at time-wise?
About a little under an hour. You want some questions?
Yeah, let's do some questions. This is the water line. Oh no, that goes on after the water system. We're gonna do that later. So the knock sensor. Okay.
All right.
Yeah, I'm ready.
Red
Yeah.
Metha.
What is it?
Red Metha
Dread Metha.
wants to know why you chose the 2020 Supra
Okay.
platform.
Question is, why did we choose the 2020 Supra platform? The reason is we just wanted to start with the newest engine, the newest car. We already work with Toyota with the drift cars that we run, the Toyota Corolla, and thought it'd be fun to just try to make high horsepower out of something no one's done it before. So it's just a challenge, and if the engine turns out like something that we want to use, which is looking like it, then it kind of opens a conversation with, what else can we do with this engine? So, yeah, that was the reason.
Yeah, I'm going to use 670. Eric Garcia wants to know what brand of oil and oil weight you use.
Eric Garcia, what brand of oil and oil weight? We use a Lucas full synthetic 5W50. And we use that on all the different cars, and it's been excellent. We also use their products in the transmission and also the rear end and their engine assembly lube. So, and even the contact cleaner. So all their lubricants and sprays have worked really well for us.
Eric Book wants to know how long does it usually take you to pull an engine, disassemble it, reassemble it, and put it back in the car?
Yep. How long does it take to pull the engine out, disassemble it, reassemble it, put it back in the car? I mean, if we were racing to do it, probably, a couple of days, I think. At this pace, as we've been filming everything, a couple of months. But it's usually half a day. You have the engine out on a stand at the maximum. Probably another half day to pull it all apart, clean everything. Another day to disassemble or measure everything, change the parts, get it back together, and then probably another half a day to put it back in.
Where do you get your torque specs from? And do you torque everything or just the important stuff? And that's from Aiden Pringle.
So from who?
Aiden Pringle.
Aiden Prinkle had a question on where do we get all the torque specs from the factory service manual. So this one for the 2020 Supra is actually available online to just anybody, we found out. So it's Toyota TIS, like Tom, Indian Sam, and I don't remember the exact, it might just be toyotatis.com, but you can go on there for like 3 days for like 20 or 60 bucks. You can get access to the whole service manual. And then they have other ones with a little bit more money, you can get access for longer periods of time. And the 2020 Supra stuff is already all up there. So what I did is I looked through the whole thing, wrote down all the different, printed out some of the procedures, and then wrote down all of the different torques. And then I put it all onto one Word document and printed that out and brought it here. That way I don't have to keep referencing the online version every time I need something. Yeah. Any questions here while I'm cleaning up? Here.
With the wheel speed sensor on the turbo, are you guys just using it for monitoring, or do you have any cutoffs associated with it?
Yep, so the turbo speed sensor, we use it to make sure that we don't overspeed the turbo. And then we can also use it for sometimes troubleshooting. So maybe we had, an intercooler end tank break open or something like that. Or just maybe we're not getting boost and the turbo's not spinning. So you can use it for both. But typically we're just making sure that we're not overspeeding the turbo, especially when you're near the maximum output of the turbo. You can have reliability issues if you're going past the designed parameters of the turbocharger.
Are you guys logging that with ECU?
We logged that with the AM Infinity ECU, and actually with that data and exhaust back pressure and a few other things, we can give that information back to the turbocharger manufacturers, and they like that because they can start potentially maybe we need a different turbocharger sizing or optimize the exhaust turbine housing sizes. So there's a lot of stuff that you can do with that data, or the engineers can do, and we can go both ways and maximize the setup that we're running. All right, so I'm gonna keep moving, and next let's do the intake manifold. So the intake manifold uses a bit of silicone to seal it up. Because it's custom and we didn't make an intake gasket yet, I'm gonna assemble it without the silicone right now here at the show. Back at the shop before we put it on the dyno, we'll probably pull it back off. We will pull it back off, put silicone on it. But I do want to get the thing on here today. So the intake manifold itself is it's actually super trick. It's something that was all CAD designed, and it now has bosses for port injectors, and it was actually 3D printed out of aluminum and costs thousands of dollars. And there's one of them. So let me get a couple of tools to install it, and then we'll keep moving. It takes these little Allen bolts. Let me see here, I might be able to, yeah, give me a hand if you would. Actually, just hold this. I don't even know if I can do it with the fuel rail in. Just get it started. Sometimes initial design racing components aren't the easiest to work on. It's like performance first before ease of working on it. Actually, could you hand me the 1/4" ratchet? Thanks. Yeah, got the 2 bolts started. Thank you. So once we get a couple bolts in here, it'll hold itself up. Yeah, you know what? It might not go on that easy with the fuel rail, but for sake of time-wise, let's get this thing mostly bolted up, and then you guys don't want to watch me put 7 bolts in. So intake manifold, air goes in through the drive-by-wire throttle body, in through the intake manifold. Fuel is sprayed through the 6 2000 cc injectors. The air and fuel go past the intake valve into the cylinder. It then gets compressed. The spark ignites it, pushes down the piston. We make our horsepower. Exhaust valve opens. It goes out the exhaust. It turns the turbocharger. That's how it gets the boost, is from the exhaust energy, and it all goes over, starts over again. The next big part we have back here is the water pump. So this is the water pump. And alternator bracket. We've actually modified it so it can take a -20 hose, but this bad boy bolts on right under here. And we do still use the mechanical water pump. And in the future, we'll probably continue to use it. We've had great luck with mechanical water pumps versus the electric stuff. But what can happen is, if you're running the engine a lot higher RPM than it was designed, sometimes you need to underdrive it a little bit. So what we'll probably do is go to a smaller crank pulley to underdrive everything. Instead of doing individual pulleys, we'll do everything. So we need the bolts. Pardon me?
Would that have if it goes smaller harmonic, would it have an effect on the crank?
Yeah, so we would go. So when we go smaller with the pulley, sometimes you leave the damper a similar size, but just go smaller with the serpentine part of it.
Yeah, so you only do. But I mean, how restricting? Yeah, not really.
So if you're online, this is kind of important. So if you stay till the end of the stream, actually let me catch everybody up. If you're just joining us, we're here at the 2019 Sema show. We're building a 2020 Supra engine. We're trying to make 1,000 horsepower out of this. We're doing the final build here at the show. If you're interested in this, we have a couple other videos on the Papadakis Racing YouTube channel you can check out. We'll be back on the engine dyno this week. So if you want to see how it all turns out on the dyno, stay tuned, consider subscribing, and you'll see the next video comes out when we do all of the dyno testing. At the end of this stream, this one you're watching right now, we're going to show one of the dyno pulls from the engine dyno last week. So tell your friends, or don't tell them, so you can say you saw it first. Actually, tell them. All right, so water pump on, and there's another contraption that goes here, which is the water outlet, and it's very kind of sophisticated from the factory, and what we decided to do was really simplify it, and we're just running a standard -20 outlet. We machined this piece out of aluminum, and it's got a -20, it's got a cap on it right now, it's -20, and it takes a couple of O-rings, and in order for me to get this installed and the O-rings not fall off, I've got this super tacky silicone O-ring lube, and I put this on the O-ring, and then when I put it into the groove, it will not fall off. And I'll do that to both. Done. And then we can install that here. So this is the water outlet from the cylinder head. It actually, water goes up to the cylinder head, it goes out through this port and out this dash 20. This engine is a little bit different. When you're usually seeing water outlets from the head on the actual head, the water outlet from the head on this is actually in the block. They did that for, I'm sure, some kind of warm-up reasons. Nowadays, there's a lot of emphasis on engine designs to get the engines to warm up quickly, because that's when the engines typically make the most emissions, and it's when they're cold, the worst emissions. So they want to try to get through the warm-up as quick as possible. And our belief is that's one of the reasons that they go to like the integrated exhaust manifold in the head. So there's actually water all around that integrated exhaust manifold, and it warms up the coolant quicker, and then it warms up the whole engine quicker, and you get to the out of that poor emission range quicker. What's up? Yeah. So the question is low tension oil rings and stuff like that. Yeah, that's been going on for a while. There were some cars from like kind of early 2000s that they started having those, but they kind of would smoke a little bit. So I think they're kind of figuring out how to do the low tension oil rings and have them last a couple 100,000 miles still. Yeah, you know, it's hard, right? You're in your manufacturer, you gotta have so many things work out for so many miles. Okay.
Is there a Valvetrain motor up on top where there's an adapter plate now, it looks like? On the
Here? Oop.
backside valve cover?
Come over and point.
I should have referred to the high pressure pump.
Right up here. Well, it's pretty common. BMW has a Valvetrain motor that runs through a centric shaft.
Here. You're online. You're live.
So I know a lot of the BMWs, this is where they have a Valvetrain motor that runs the eccentric shaft to help make for the VVT.
Yep.
Did you use adapter plate, or is that just how they come in the Supras?
So this is where the mechanical pump for the direct injection goes.
Okay.
And then over here, this black thing is the motor for the variable valve lift.
Gotcha. Okay. Perfect.
Yeah.
Thank you.
Yeah, no problem. I just set it there. So this is the combination air to water, or coolant to oil heat exchanger. So it's like the oil cooler, and it uses the coolant to cool the oil, and then the oil filter housing. So I'm gonna bolt that on now. And I actually like this a lot because it's all integrated in a tight little unit. So I need a socket. Let me see if I can get it started a little bit so I can leave it here and grab the socket. We're leaking oil. All right. So I'm getting one size bigger Torx socket. So we're getting there. We're almost done with the whole build. And then we'll do one last round of questions. So if you've got any questions, and maybe you asked it earlier and then it didn't get answered, kind of repost it on the chat, and it'll kind of freshen up Jen in the back, who's getting the questions for me. And then once I get this thing bolted on, we'll move on to the questions. And then again, like these plastic units, you got to make sure that you tighten it sort of evenly and like in some kind of crisscross pattern, because you don't want to tighten like one corner first and then potentially like crack it or something. What was that? Yeah. Mia. And then one more thing back here, Dylan. Where did we go? So this is where the oil filter goes. This is our brand new oil filter, which I actually like these paper filters. And then Which way does it go?
Built the bottom. Built the wall here.
That way.
You're a BMW mechanic. Which way?
This way goes this way.
How do you know?
Because this is too
Oh, it
big
should
for
lock
here.
in, yeah.
Like when you actually push it down, you put it here, and you push it, you get
He's a BMW Master Tech. From where?
Toronto, Canada.
Canada. Nice.
BMW.
And then that goes in here. And then when I tighten these, I just kind of go till it stops. And then no, don't torque it because you can crack these things. Done. That's it. And we got a couple of small like sensors and stuff, but I'll probably, why don't we skip those for this because I don't think it's relevant to our bigger project here. And I want to get to the last few questions, right? But before we get to the questions, I think it's kind of interesting like the setup that we had here for the live. And can we go on this camera? So Dylan, our buddy's been on the handheld kind of moving me around the last few days. And there's a couple of GoPros set up that are all, you know, one here on my right, and then one up here pointed down, and there's one kind of like this establishing shot one. Can you go to that one? So Austin is in the back, and he's controlling all of them. So let's check this out. So Dylan, can you back up and check out the, I think it's super cool. So come around this side. Do you end up with some weird like warped reality if you're filming the filming, but so he's got this laptop and the software that he can switch in between all the different cameras, and it's just super trick. And then it goes up to the YouTube live stream, and
you can just tap it.
this is the
It's a
so,
switcher, see?
so how do I switch to another cam?
Yeah, it's a camera 6, then click auto.
So we just switch to another camera through this iPad interface.
Press it again and we'll go back. Yeah, there you go, hit 4.
Yeah. Okay, how do we get back to Dylan?
1, and then hit auto.
So Austin's been helping with all the technical side. We've got Lonnie here that's helping with the whole deal. And then Jen has been moderating the questions. So yeah, next question.
Alex Kajeri,
Alex Kajeri, okay.
what do you plan to upgrade in the Valvetrain? Are you going to have bigger cams made?
Yep. So what do we plan on upgrading in the Valvetrain? So far we've upgraded to a SuperTech valve, spring, retainer, and keepers. So they're valves capable of higher temperature, springs that are stiffer so we can deal with higher RPM and the extra boost, and then titanium retainers that are a little bit lighter than the steel ones so it can help with higher RPM. We are using stock cams initially. We'd like to use larger lift cams that allow more air in and out of the engine, so potentially we can make more power at a lower boost level, but that's something that we haven't gotten our hands on yet, but it's on the list of something we want to do in the near future.
Tommy wants to know who taught you how to safety wire.
Tommy wants to know who taught me how to safety wire. I don't know if you're critiquing in a positive or negative way, but I just, you know, not any formal training. You read some of the books on how to safety wire, and I've read some of the Carroll Shelby Tune to Win or Race to Win books from back in the days. So he had a whole section on safety wire, and then you can go online and learn stuff as well. There are debates a little bit on how to perfectly safety wire, but I know there's definitely some proper technical ways. I do it in a way that I've seen as reliable, and it's worked well for me. But I don't know, I wouldn't go and safety wire an aircraft because I don't know exactly the perfect way of doing it.
There have been a few different questions about the composite on the plastic on the top of the engine. Manifold wants to know, have there been any plans to 3D scan the head cover to make a different one in a different material? And then
What was it?
Dylan's asking you, is it weird that they're starting to use plastic in engines?
Yeah, so Dylan and Manifold asked questions about the valve cover. Is there any plans to do a non-plastic one? I'm fine with the plastic valve cover. It's lightweight, and it hasn't shown to be any kind of problem. But if somebody made like a dope billet aluminum one that wasn't necessarily heavier and was maybe higher functioning, we would totally consider using it. And what do I think about the different plastic parts? I mean, initially, you don't think that they're maybe as strong, but they haven't seemed to be less reliable. The aluminum stuff, they tend to just be a little bit less weight. So I'm kind of indifferent about them at the moment. Yeah.
The final one is Falcon Trust wants to know, do you expect this engine to be able to run as much boost as the 2JZ?
Do we expect this engine to run as much boost as the 2JZ? I'm hearing those guys are running like 70 or 80 pounds per square inch or something crazy like that. Man, I don't know. They've been developing those engines for like over 20 years, and that thing's super buff. In the first few years running that kind of boost, I doubt it. In the future, I don't know, man. If someone cares that much about running this engine and trying to make whatever they make 2,000 plus horsepower, then I'm sure people can figure out how to do it. But initially, it's going to take a lot of work to try to get to there. Yeah. What are we doing timing-wise, Jen, on the whole?
30, half an hour.
Oh, still half an hour. Okay. So I will. Any questions here from you guys? Yeah. So, Dylan, you want to come around? I'll show you what he's asking. So, and I'm sure a couple people may have seen the turbo manifold. So, the turbo manifold has the 2 ports. These are wastegates, so these are what regulate the boost by, instead of allowing the exhaust to turn the turbo faster, they bypass it and just go out to atmosphere. There's back pressure in this manifold, and we are using these, the back pressure from the engine dyno, the sensors hook up to this port that reads the manifold pressure in the exhaust manifold. These just have a void in them, so they're just sort of open inside, and it can reduce the pulses, because each time the exhaust valve opens, you get like these pulses, and it's a little damper to try to dampen that. Yep. The second port here is where the EGT, exhaust gas temperature probe, goes. So we're getting both the exhaust pressure and the temperature on both of the exhaust ports.
Okay.
Yep.
What is that called?
Do you
Yeah.
prefer the 2JZ or the B58?
Do we prefer the 2JZ or the B58? I mean, initially, if you're just looking for like low cost, easy to tune, go in a catalog and build a 6-cylinder engine, then the 2JZ is hard to beat for sure. This one, I prefer to tune it and build it because it's a challenge right now. There's so many people that build 2JZs better than I could build it, and they're already kicking butt doing that. So I kind of prefer this as like a project for sure, because then we can try to get out ahead, you know, and then have people try to catch us, versus trying to catch somebody else at some like almost unobtainable 2JZ horsepower number. Like, those guys are such pros working on those engines, and they just work on them day in and out. I don't think I could build what they do. Yeah.
Cool. Do you think this has just as much potential as a 2JZ maybe in the future?
Does it have as much?
More developed?
Yeah, does it have as much potential as the 2JZ? Man, I don't know. Like, for us, we want a lower weight engine and maybe have a good balance of like low end torque and high RPM power. And maybe with the newer technology in this, and it could lead to more of a broad power band at a lower weight for the engine. But you know, that's what we're kind of finding out, right? That's what's kind of interesting about the whole project, is how does the engine compare to the 2JZ? And I haven't totally determined that yet, but we'll share, you know, this whole process, and you know, you can determine, you know, kind of for yourself. That's what's fun about this whole deal. So let's keep going with a couple of sensors on the backside. This engine takes 2 knock sensors, and what the knock sensor does is it's like a little microphone, and it listens to the block. It listens on the block, and if there's knock, it actually will get extra sound, and the ECU will record that sound and let you know that it's knocking. And it can even do things like retard the timing. So those sensors are these, and there's one that goes on the front and the rear of the block. And because the engine control system knows which cylinder is firing at what time, if it hears knock during that timing, it knows that it's from a specific cylinder actually. So that's what's cool about the modern ECUs, is they can actually tell you which cylinder is knocking. And typically on these inline 6 engines, numbers 5 and 6 will be the most sensitive to knock, or the most susceptible to knock, and the most likely to knock, because they're typically the last to get cooled, so they typically run a little bit hotter. And the way the intake manifolds are designed, the number 6 cylinder, the air just, it's easier for the air to flow into number 6 versus making that sharp turn and get into number 1. So number 6 typically will get more air than number 1. So 2J guys and most inline 6 guys, if they blow a cylinder, it's almost always number 6. So, you know, on our 4-cylinder engines, and even on this, we'll probably put a little bit extra fuel in number 6 cylinder. And with the modern ECUs, you can actually trim a little bit more fuel on cylinders that you may want. It's a little bit more challenging on this one because there's only 2 exhaust ports. We can't put EGTs on all 6 cylinders and then tune them individually that way. We just have to sort of use an educated guess a little bit, or pull the plugs out and try to read those. Another sensor we have is this one. So this sensor is the crank angle sensor.
Got it.
And it fits into the back of the block here. And it reads the location of the crankshaft. And then on top, these 2 sensors, this one and this one, read the location of the camshafts. And if the engine, or if the ECU knows where the crankshaft is and it knows where the camshafts are relative to each other, it can then do a feedback system and adjust the variable cam. So if you say I want 5 degrees advanced or 40 degrees advanced, it knows the phasing, and it can start duty cycling oil into that cam gear and start changing where its relationship to the crankshaft is. Once it gets to that 40 degrees or whatever you have programmed, it'll keep it at that location. If we'll come around this side, we'll put the water port on. So this hose leads from the water pump up into the cylinder head. It goes this way. And that takes these Torx bolts, which let me get through. So if you can't see me right now, I'm digging through the toolbox. So we'll go ahead and screw those on. And this is a factory water line, which seems totally fine for what we're doing right now. And then once we kind of, if we ever put this into a car, then, sometimes you get into the next phase where you start, working on all the water lines and, the trick cooling system and everything. We're just kind of doing enough now to get away with what we need to get away with for the engine dyno. But when I initially did some, figuring it out on the engine how the water system works, I actually sat down with this thing in the engine building room, and you kind of just start looking and see, okay, well, the water pump turns this way, and water comes out here, and it comes into the head, and just trying to figure out, get a really good handle on how all this, the cooling system works on it. All right, next, let's put in so this is the oil control solenoid. So this is the ECU duty cycles this solenoid, and this is what actually sends oil back to the oil pump and adjusts the oil pressure. That fits into the back of the block here. So I'll just sort of make sure it feels positively installed and then bolt it in. Oop. I love this ratchet. Okay. There's another, this is one of the crankcase breathers, which is this. That bolts right there. So you know we're getting to the end when we're doing all the small stuff. What's up, Jen?
Do you have any recommended engine building and upgrade books or tutorials, and do you offer any classes? And that's by Captain Zero.
Captain Zero had the question of, do I recommend any books or anything on how to build engines, or you know, any schools or anything like tutorials? Man, I haven't. No, I'm trying to build that here, man. So I guess try to watch our videos and try to get an idea of what we're doing. So I think even between a service manual and reading through the suggested steps on how to disassemble and reassemble, and then watching other people and how they're doing it, and then you go in and start doing it yourself, you will just start getting experience through that way. And then if you've got any kind of buddies or anybody that works on engines, or even a technician at like a dealership or something, and you reach some sort of roadblock, you know, hit them up and ask them a specific question on how to get through there. It's a good question. Yeah. So we are almost done. There's another water port that we're actually not using. So we just welded a fitting and then capped it. Sorry guys, it's this one goes on the other side. This one goes here, I believe, yeah. So this one is part of the turbocharger cooling lines, but we're not running coolant through our turbo. We're only running oil. And it's not always recommended, although we've got fine results from only running oil through our turbochargers. But if you're going to go run endurance racing when you're on, you know, or street even, sometimes when you park the car and it's hot, the coolant can help keep the center cartridge cool and have the turbocharger last longer. This fitting right here is for the oil pressure. So typically there's a sensor that goes here from the factory, but we're running an external sensor. So we just have that bolt in. And that's a 9/16. We're actually starting to run out of parts. That's good.
Are you going to use the oil level sensor to determine oil level, or are you guys putting on?
So oil level sensor, the question is, are we going to use the oil level sensor? So to give you some context of what's going on, there is no dipstick in this engine. The way the factory works is it's got that a sensor in the oil pan. We haven't yet figured out how to utilize that sensor. It's not a 0 to 5 volt sensor. It actually sends out a digital signal. So we're still working on utilizing that sensor. So right now, how we're checking the oil level is we're actually pulling, we know it takes, I think it was 7 quarts or 7 liters. So we know the engine's dry. We'll put the 7 liters in it, and then we take the oil drain off, and then you can look in there, and we made our own little dipstick to see where that level is, and we just check it intermittently that way. But eventually we're going to figure out how to use that oil level and temperature sensor, and then we'll have that digital way. But that's one of those things where the technology is a bit ahead of the aftermarket and some of the teams, but that's some of the fun stuff, is to reverse engineer and figure out how the factory does it. And what'll end up happening is, initially you're like, dude, I want a dipstick, and I kind of do want a dipstick, but soon we'll have live oil level on the readout of the dash in the car. So if we build like you have that in the factory Supra, but if we build a race car with this and we can use an aftermarket dash, we can just like you have a fuel level, you can have oil level. And that's the newer technology allows you to do that. So I'm pretty happy with how far we got with the engine, which is everything other than silicone on the intake manifold and a couple of bolts on the turbo. this thing's done. So we can actually keep, do you guys have any other questions or anything? Jen? 15 minutes? I can start talking about some of the things that I get asked often. Yeah, so another question I get often is, do we have internships? And there's only a couple of us at the shop, so we actually really don't have internships. The cycle of the team has been, with the drifting, is we start our drift events we start testing in March, and then our drift events start in April. We're typically on the road from April all the way to October, and then right after the last drift event at Irwindale, we're getting ready for Sema here. And then we're back we usually take a few weeks off after Sema, and then maybe we have a project where we're building a new competition car or something. That'll happen at the shop between December and February, March. And then same thing, we'll test with that car, and then we'll go into the season again. And we usually have a couple of different teams. There's only 3 of us that are full-time at Papadakis Racing, Aldo, Sean, and myself. And we do everything from the fabrication of the car and the design, and also at the track. And then we have specialists that come out to the different events, and these guys are really good at wrenching on the car and fixing stuff when things go wrong. But typically they have other 9-to-5s throughout the year. And then if we're building a car in the winter, we have a different set of guys that are really good at fabrication, like roll cage and sheet metal and building the chassis. And sometimes the guys that are really good at the fabrication are not always the guys that are the best at the mechanics side at the track. So nor do they want to go to the track. They'd rather be building stuff at the shop than like swapping tires at the racetrack, right? So it's a lot of time it's a different person. And that way we can have sort of masters at both throughout the year. Yeah, okay. So thanks for watching. We'll probably wrap a little early just because, we're all done. So thanks for watching. Stay tuned because we're gonna show a run of this on the engine dyno. If you like this stuff, if you like the video, please hit the like button, the one you're watching now. If you want to see more, please consider subscribing. Again, we're going to be on the engine dyno with this. We're still trying to make the 1,000 horsepower. We're going to edit that whole video. It's going to go up on the channel. So if you're subscribed, or if you get notifications, then you'll know right when that video comes out. And are you guys queued up to run the engine dyno video? So here you go. Here's a run from the engine dyno. We won't tell you the horsepower, but soon when the video comes out, you'll find out. So thanks for watching.